your head area and you have your body area, and here I have this div ID equals messages, and it's just empty right now, right? So I could just kind of do it like that just to show it's empty, or do it like this to show it's empty. And when I go over here and I say document.getElementById messages, it's down here where I'm appending a child to that messages div. So I'm saying messages.append child. So that would be the same as just typing div head. Would be the exact same thing. So I'm creating a div called content. That's the variable name I'm giving it. And then I'm setting the inner text to my message. And then I'm appending that content to the messages area. So let's see. So I'm adding, effectively what I'm doing is I'm adding the message to the messages, but I'm doing it inside of this content div. So if I went like, here I went like div cool, like that, and I'm going to save all this, Command R to refresh my page. So if I go, hey, cool, if I view the source on this page, it already says, hey, cool. Sorry, actually, I'll do it over here where we can look at the elements. So it says, hey, cool. And if I go right here and I say, hey, to, now that div was appended to this. So it's a hierarchy where you have parents and children, right? So this content div that I added is a child of messages, and I'm appending it, which means that it's going to become the last child in that hierarchy. So if I say cool to, it's going to be appended, and again it will become the last child. So cool to is now there. Does that answer your question? I think it's really just about having in kind of as you're going, keeping track of like the visualization of what's happening to your HTML and the structure of it and where the children sit relative to their parents. But it's always really helpful to open up your console, click on the elements, and actually look at how your document structure is changed. Again, that's sort of if this were a submit button by default, I'll actually show you an example of that. So if I'm going to create a form, and I'm going to end my form down here. So my inputs are now inside of a form, and this is a submit button. And I'm going to, where I say return add message, I'm just going to leave that right now. So I'm just going to say, not make any changes. All I did was add that form, right? So if we refresh the page, now you'll see that the two inputs are children of that form. And I'm going to say, hey. So that's cool. And cool. If I go back now and I say return true, refresh my page and say, hey, notice the page refreshed. So I'll try to send cool now, and I'll hit send, and the page refreshed. And you can get an indicator that the page actually changed because this question mark was added here. So if I go back here and I say, hey, watch when I hit send, you'll see the refresh button will actually flicker, and the question mark will be added up there, so I'll hit send. So it refreshed the page because what it thought, and actually I'll go over here, I'll say preserve log, refresh the page again, I'll say hey. Sorry, actually if I go to network. Okay, so on the network, if this is red, it means it's recording. You'll see this actually refreshed, and if I do it again, if I say cool and I hit send, it refreshed. Each time it was actually going, it was grabbing the index in the script, the index in the script. So it was a full refresh, and what's happening there is it's actually submitting that content to the server. So if I click on this request now, you can see what that request is doing. So it's requesting this simple chat / index.html. Sorry if that's very small, with the question mark. And if we went over here, it's going to create a hidden input on the page. And let's see if that doesn't. So when you make a hidden input like that, it's a way of storing values in your form that don't actually display on the page. So you won't see that whatever value here. But if we go over to elements and inside the form, you can see there's actually a hidden value here. So I'll say hey to, and we'll open up the network. I'm just going to clear it. We'll hit send. Oh, sorry. I need to say, so inside of our form, we need some options. So we're going to say method equals get. What should be happening, I think I messed something up here. Oh, I need a name. That's right. So this name would be something. So input type hidden, name equals something, value equals whatever. So I'll save that, clear it, and we'll say hey to and send. And now if I click right here, you'll see that the URL that was requested actually sent that value to this page. So we were on index.html, and if I say what's up and hit send, it's sending something whatever. So it's sending that hidden value. So I'll make that a non-hidden value now. So I'll delete this, and I'll say input type equals text, name equals new message. So we can say location.href, and it's going to give us a URL of the page. And if location itself is actually an object, and we can open that up and we can look at the object, and we could look for this search part of that. So if we say location.search, it's going to give us that value, and we could actually parse the values out of that message. So the reason that's useful is because if you wanted to send information from one page to another page, a really common way of doing that is through the URLs. And we don't want to do any of that. So that's kind of like the default behavior of the browser when you have a submit button. It's going to submit your form by default. And if we return false, what we're doing is we're telling that submit button that we don't want to submit any of this. So I'm just going to go back here. I changed that value in JavaScript back to false. And I'm just going to refresh this page. And I'm going to say hey to. And now it's just adding the message to the page, but nothing's actually being submitted. So a submit button by default will submit a form. In our very simple example, we don't have a form. We're not even giving it We're not even giving the input a name because we don't need a name because we're not really, this isn't really a form that's being submitted to the server in this case. And we're returning false just to prevent that submit button from actually doing anything to the form. So I'm going to change this back to a button, and I'm going to remove that. So on click, I'm just going to say add message, and I'm going to delete this. And then again, you'll see another difference between a button and a submit is that a button doesn't actually try to submit a form. So I'll say hey to, and it works. And it's kind of a simpler example because you don't have to do the return. I use submit just out of habit, and a lot of times if you are creating a form, you want to use submit. That's oftentimes the only button you have in your form. But if you're just using type button, it kind of simplifies things because you don't have to worry about your form being submitted by mistake. So long answer, but I think that deserves just a little bit of background on how the browser views those things differently.
Yeah, we're good.
Okay, so let's move on to this server now. So I'm just going to look at, read through this quickly, blah, 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 web framework. First, let's create package.json. Socket chat example with a version. It's going to have dependencies. Wants us to install Express. App.get. HTTP.listen. Localhost. 3000. It's doing this. It's going to send the index.html file. Populate index.html with the following. So they're doing a lot of what we did with the chat UI already. They want us to install socket.io. Here we're, let's see. Oh yeah, we're passing in the HTTP server, so we're attaching socket.io to that HTTP server that we already created with Express. And then we're including socket.io on our page. We're adding some connect code. User disconnected. Then we're going to emit events from the client side. They're including jQuery. Okay. Then we're going to broadcast messages. Blah, blah, blah. So you can find the whole thing on GitHub over here. So they have their index.js. We can see the completed version. Oops. They have index.html. We can see everything they added there. And the package.json. So, I mean, the easiest way to do this would just be to we'll walk through each of these steps. So I'm going to create a package.json. So from here, I can do a I'm just going to create a new file. In Vim, you do that with E. We'll create a new file. We'll call it package.json. So this is kind of the same as just doing like touch. Save that. Now npm install -- save express. So -- save, what it does is it will add express to this dependencies area right here inside of my package.json. So I'm going to command Z. I'm going to type that command. It's going to install express. All of these things that you're seeing here, these HTTP gets, Express is downloading its own dependencies. So you can see here where they've successfully installed the dependencies that Express has. So if I ls now, the thing that I didn't have before that I have now is this node modules directory right here. So if we cd into that directory, we're going to see Express. So if I ls, see Express. Express is a thing that we installed. It's a node package that we installed. And if I cd into Express and ls, you see all of the files that are part of the Express project. And Express itself has its own node modules. So if we cd into the Express node modules in ls, I'll ls minus al, so it's like this. These here are the things that were downloaded as you watched Express download all of those dependencies. You'll see that it actually added it inside of the Express node modules in your directory structure. So you can see cookie signature and parse URL and these types of things all down here as well. There's parse URL. There's cookie signature. So what directory I'm in right now, print working directory, and I'm just going to cd back a few times. cd ... just goes back a directory. I went too far. Oh. Oh yeah, I'm in development. Sorry, I have to go to my simple chat directory. ls. Okay, so does anybody have any questions about that? When you're doing an npm install, what it's doing is it's downloading a project, and that project would be on GitHub. So if we search like GitHub Express, we would find that project, and if we look inside of the package.json for that project, we would see that that project has its own dependencies, and you'll see that these look familiar: cookie signature, parse URL, etc. It's going to download each one of these, and each one of these have their own GitHub project as well. So if we went GitHub cookie signature, you'll see this project called Node Cookie Signature, and you could install this directly by typing npm install cookie signature. And this has its own package.json, and it has its own dependencies, and each of these packages would. So there's a whole hierarchy of dependencies there, and what you're doing is you're downloading each of those, and by cding into the node modules directories for each of these projects, you can explore all of the dependencies that have been installed. Does that make sense?
Yeah. So Gavin, we always install the node modules into whatever project we're working for. We don't try and do that globally anywhere. Is that correct?
With the exception of a utility, so sometimes you have an npm package that you install that will actually that you want installed globally, because you're going to use it as a utility across all of your projects. But generally, as a dependency, you just it would install every time. So if you had exactly that, you had 10 projects that all used Express, then you are downloading Express every time into that project. So it's actually sitting on your computer and taking up hard drive space 10 different times.
Yeah, no, that's what I thought. So
that was I did not do that, so that was definitely a hurdle.
I have one question as well. If you have something in your package.json, does it duplicate it each time that package is referenced, or does it know that it only needs to download it once in your project?
If a dependency uses the same dependency as your main project, is that what you mean, or?
Yeah, that's what I meant.
So let me think about this. It will create a new copy of it. So if let's say we were using this this cookie signature, if we wanted to use cookie signature inside of our own application, then we would npm install cookie signature, and then if we looked at our package.json, Oh, I spelled package.json wrong. So I'll have to fix that. Sorry, cat package.json. So if we looked inside of our package.json, it would have become it would become a dependency in there. And if Express also used cookie signature, it would be a dependency inside of Express's package.json, and it would actually download it every single time. And the reason it does that is, in this case, we're just kind of npm install, cookie signature, and we're just getting whatever the latest version is. But it could be the case that Express was using a different version than we are, and because of the kind of complications that can come up with multiple versions of things. It just downloads it every time. So in some senses, in terms of disk space, it seems very wasteful. But in terms of having like an organized project where you're very clear about exactly what your dependencies are and any version differences between similar packages, it's a much more kind of organized way of doing things.
Thank you very much.
Okay, so I need to fix this. I made an error here, so I'm going to do a move my wrong spelled package.json to package.json. So if I ls now, that should be spelled properly. And because I had that spelled wrong when I did npm install -- save, it actually wasn't able to find package.json. So I'm going to do that again. So you'll see inside of my dependencies, it didn't actually add it to the file because it couldn't find it. So I'm going to npm install -- save express. And hopefully now if we do a cat on our package.json, yeah, so it actually added express this time. So just to show you, we could do npm install cookie signature, npm install -- save cookie signature. We'll install that in whatever dependencies it has, and then cat package.json, and it added cookie signature. And what they're saying right here is express any version greater than 4.9.8 and cookie signature any version greater than 1.0.5. So now I'm going to npm uninstall cookie signature because we don't actually need it. Oops, I copied that by mistake. npm uninstall cookie signature. Okay, so maybe that doesn't remove it from the package.json when you uninstall like that, or maybe there's a command that does it, but I'm going to open up package.json now, and I'm just going to delete this and get rid of this extra comma and save it with, in vi, you do :w to save, and then :q to quit. And now if I cat my package.json, you can see that I removed that dependency. So that's basically how npm works. It's a dependency manager for all of your it's a dependency manager for your Node.js application, and dependencies are a thing that you should definitely use. Like you should use Express, you should use Socket.io, and you should use whatever the Node Redis package, etc. And all of those are using dependencies themselves. But you should do that because you don't want to like reinvent the wheel every time. There's a whole open source community out there of people who have created a ton of these projects, and they're all community reviewed, and they're all collaborated, and they've considered things like security, and they've considered things like performance, and they've also put hundreds of hours into these things. And you don't have time when you're creating your application to do everything from scratch. So having knowledge of the open source community and all of the projects that are out there and the projects that are popular, and the and having skills to kind of search GitHub and to search npm for projects that might do what you're looking to do is something that's really, really important to getting your application up quickly. And it's also really important in production environment too, because they have considered things like performance and security. So any questions before we move on to the next part of this?
No, I think we're good.
Okay. Okay, so let me see. They want me to create an index.js, and I'm just going to copy this. I'm going to go back to where we had all of our other stuff. I'm going to open up a new file here. And I'm going to call it index.js. And just by saving that, you'll see if I ls now, I have this index.js file. So I'll go back to that. When I'm done this too, I'll throw the whole thing on GitHub so you guys can take a look at the code. Okay, so var app equals require express. So when we say require, what we're doing is we have express in our package.json file, and by saying require, we're saying we want to use this inside of our code now. So we now have this app variable that refers to the express project. HTTP equals require HTTP.server app. So now we have a HTTP server that we're able to listen. This is listening on port 3000. So console.log listen on, port 3000. So app.get slash, that means whenever we go to the root of our project, so if we were on localhost port 3000, we would just go localhost colon 3000, and by hitting enter, it's going to go to the root, and without specifying a path, it's going to go to this route inside of our Express application. If we wanted to change this to /app, then we would have to visit HTTP localhost colon 3000. I realized I would typo there, /app. And that would go to the app route. So you can add multiple routes in your application. If I just copy that whole thing, paste it, I could have like a / route, and I could have an app route. More commonly, you would see like a login route. You would see like a dashboard route. On Facebook, they have like a profile route, different things like that. So we're just gonna stick with that main like root route. So anybody who goes to the root of our application is gonna land here. And what we're gonna respond with is hello world inside of a header tag. So let's just do this. We'll save it. We'll type node index.js running on port 3000. So let's go localhost 3000. And we see that hello world. So if we inspect, we look at the network now, and we do a refresh on this, you'll see this request being sent. It's a GET request. It's being sent to localhost /3000. It's returning text /HTML. The size of the content that is returned is 206 bytes. It took 3 milliseconds to return that, and we received a status code of 200, which means all is good. If we click on that, you can see this happening. The remote address is actually 127.0.0.1, which is the home address of your local computer. You'll see the status code. And you'll see this is the request that the browser actually sent to Node.js. We sent our user agent, which is, in this case, Chrome version 38. And we sent some information like no cache, keep alive. We sent our language that we accept. We accept US English in this case. We accept certain encoding like gzip. And we'll accept a text HTML file, or these certain types of images or some other types of files. And so that's a request. So in the request to response model that we talked about, like way back in the first week, the browser sends a request and it looks like this, and it's saying, I want this URL, and this is a GET request, and I'll accept these values, and this is who I am, this is my user agent. And then the server, the application server, responds back with this information. It gives us a content length, which is the size of the content. It says this is content type text.html. You'll notice that it matches the text.html that we said we would accept. It gives the date of the request that it was returned, and it says powered by Express, so we know what server we were powered by. So if I went over to here and I just cleared this out and I click on network and I go to, I'll go to google.com, let's say. Same thing's happening. So a request is being sent to google.com. There's, a bunch of information in it, and then Google responds with the server that they're using, the location of the request. It's text.html again. So everything just works this way. The browser sends a request, and the server responds with a response. So you can kind of click through here, and you can see, here's my profile image was returned by Google, and some different other things like that. Here's some kind of spinner icon. You can see, the content type is image/GIF, so it's a GIF image. There's date. There's all this type of stuff. So the basic, request response, and you can dig in. You can use Chrome and this network tool in Chrome to kind of see what's happening. And as your applications become more complicated, it's good to be familiar with this network tool, because if you're having a problem, you can look into this information and be like, okay, it's returning HTML. It should have returned an image or something like that, and it can help you debug your application. Any questions about that?
No, that's good.
Okay. So I'm going to Control C to kill that server. I'm going to come back here, and I'm going to go back to this chat project, blah, blah, blah. Express. So we define a route handling / gets called when we hit our home page. If you run Node, you'll see the following. Okay, so we did that. So serving HTML. So okay, we actually want to send the file. So inside of our app.get, we're going to do this response.send, and we're going to send our. So instead of sending just whatever text we wanted to here, we're going to send a file index.html. So I'm just going to comment that out for a second, and I'll just show you, quickly response.send whatever we want, and that's just going to send text back. So if we run our server. Right here, it's just going to send that text, right? So, and if we wanted to send a input type text value equals whatever we want, we could do that too. So I'll just do that quickly, run that, and it sent an input. So all we're doing is just sending back HTML, right? So we're not going to do that because typing inside of that little parameter area would be a really awful way to develop our application. Instead, we're going to send a file, and that file is going to be called index.html. We actually already created a file.index.html, so let's just see if this works simply. So path must be blah, blah, blah. So it couldn't actually find the file that we specified. So let's go back here and see what they said. Populate. Okay. Instead, we're going to create an index.html file and serve it. Populate index.html with the following. Wait, so that should have worked.
Gavin?
Yeah?
Gavin,
Yeah.
we had this bug, and you need to send it to the directory. So you have to do underscore their name plus index.html.
Right.
We didn't have it in the tutorial, but
Right,
that's how it was for us.
Yeah.
What do I type?
Underscore their name.
Okay, so that's
The reference to the present working directory in Node.
right, because it right here, path must be absolute. Specify root response.send file. Okay, so let's do that. So we'll run index and oops, wrong place, localhost. Dir name is not defined. Did I do that right?
I think it needs to be lowercase, but
Okay, and then I just need a slash. Okay, so that works. So if we were confused by that, we could do console.log dir name, and we could actually see what that value is. So whenever we do a request now, the dir name is going to be output. So it's users, Gavin, development, simple chat. You'll notice there's no slash on the end, and that's why we had to add a slash at the beginning to get a defined index.html. So I'll delete that. Okay, so let's go back to chat now. Blah, blah, blah. They have all this stuff here. It's kind of similar to the stuff that we had. So they want us to install Socket.io now, so let's do that. npm install Socket.io. Socket.io has a ton of dependencies. So if we were to do the same thing again, we could look into the node modules directories and we could see what all of those are. So it wants us to add a couple things now. We're going to add this. Oops. Okay, so we're going to add that. Send file, that didn't change, but this part here is new. So now we have this IO thing, so we're saying IO equals require Socket.io, and we npm and installed Socket.io, and it's part of our package.json file, and that's why we're able to require it in this way. And then we have HTTP, which was the server that we already created. So IO is kind of attaching itself to HTTP, meaning that it's going to listen on the same port 3000. So when we say io.onConnection, we're now using Socket.io methods. On is a method that they created, and on a connection, we're going to console.log a user connected. So nothing's really going to happen there, but it would say a user connected if a user connected. So nothing's going to happen right now because we have no user connecting yet. Oh, I didn't run my server. So I'll clear all this, make sure I have no errors. Okay. All right, so let's go back here now. Notice that blah, blah, blah. So we're going to include this script now. We'll put it at the bottom of our page. So now it says a user connected because we added the code to the client side. So that all happened kind of fast, but basically what we're doing is we are including the Socket.io script, which is being served by this IO server, and then we're saying var socket equals IO, which is establishing a connection. So it all happens really fast, and there's a lot of magic, and that's really nice. It's good to understand what's happening there, but it's really nice once you understand what's happening to have all of that magic and to be able to connect so easily. So we'll just take one quick look at this. We'll run the server again. Clear this out, refresh it. If we look at the network now, you'll see socket.io.js was served. So if we call localhost socket.io socket.io.js, if I copy this, paste it into the browser, it's just going to return that file. So this is all the code that Socket.io has on the client. It's probably a few hundred lines of code here that you didn't have to write. Socket.io wrote it, and it's kind of battle hardened, and it's production, and it's really good. So that's why open source is awesome. And you'll see information about this file here. So you can see a request, how we're actually serving that file. Now, if we click on these down here, so the JS file was served, but there's these EIO things that are happening. So it's saying transport equals polling. So you'll see how this is really similar to that request we were seeing before in the browser, where it said it was like question mark whatever equals like hey, when we were just doing that quick example. You'll see here that Socket.io actually has a purpose for that. So they're saying question mark EIO equals 3, transport equals polling, and T equals this number. So T is probably time, EIO equals 3. I don't exactly know what that means, but it means something to them. And transport equals polling. That means XHR polling. So we talked about that briefly before. If you want to know about XHR polling, you can Google it, and you can read about that transport. So if we click on the next one now, what was the difference? So the next time it called this EIO transport polling, there was a new time. The time slightly changed by like 100 milliseconds from 763 to 852. So it probably is a timestamp in milliseconds. And then it says SID equals this crazy value. So this SID, I would say, probably means socket ID. So that's something that Socket.io is doing. And if I click on the next value now, it says EIO still equals 3, transport equals WebSocket, and there's an SID. The SID didn't change. It's the same value. So that probably is our socket ID, or what Socket.io would consider our connection ID. That's how Socket.io actually keeps track of us as a client. But you will notice the transport to WebSocket. And WebSocket is an upgrade that happened. And WebSocket is a faster protocol. It's a way of sending messages to and from a server. And it breaks the traditional request-response flow of application servers. Normally, a browser would always have to request, and then a server would respond. But with WebSocket, you actually have a situation where a server is able to push information to a client without the client actually connecting, without a client actually requesting it. So what a client does instead is it uses request response to connect to the server, but once that connection is established, a server can at any time push new information to that client.
I have another question. I tried to access the socket object when you initiate a connection, and when I tried to look at what that was comprised of to access like the SID, it gave me a circular reference error, like the socket contains an instance of a socket. Access that SID. You know how I would go about doing that if I wanted to store that?
You want to store the SID?
Yeah, it's like a unique identifier for a connection.
If we go into here, we have this IO.on connection. So you're saying you did a console.log on socket, so let's just do that. So I'm just going to console.log the socket. So we'll run this, we'll run that, and what happens when we console.log that is we get all of this information. So this socket object, it was connected. That's probably our SID right here.
Okay, I got a circular reference error, and it wouldn't actually show me the socket itself. It would just log that error.
It is saying circular right here. So this string here, you'll notice, so it looks like one, let's just look at the last part of it, is 5P and 4A's, right? So if we look into the request, you'll see 5P and 4A's. So that is like your unique ID for this client. And this connected method here, if we say socket dot connected, that would show us this value, which is an object containing that ID as the key, and it's containing circular as a value, which means that the value is actually the socket. So it's sort of self-referencing. And then, of course, the socket would then, again, contain this value. So that is a weird sort of thing that Socket.io does. And here's ID. So socket.id is probably what you would want for in this case. So let's see. Here, just put socket.id. If we run that now, we're just going to get that like cute little ID value. Yeah, so the ID changes every time we reconnect, which is something you'll probably want to be careful of if you plan on using the socket ID for anything in your application. It seems like that socket ID is changing every time we reconnect, so it's probably not like a great way to identify the user. But I'm not sure if that's your use case or not.
That was the use case early on before there was any persistence to the data. And the reason I was getting that circular error, I realized now, is because I was actually stringifying that object. So when you try and stringify the circular, it would make like a big nested loop of sockets.
That's exactly correct. So what stringify does for everyone else is that it turns an object instead of like variables and things like that are kept track of by the computer and references to objects and these types of things. If you stringify it, it's literally going to turn it into a string of like characters. So when we do a console.log, it is in some cases we are turning that object into a string that we can read like this. But you'll notice what console.log does is if there's any circular references, so that's like that means that this value is the same as the value of the actual object. It just puts the word circular rather than just printing the whole object again, because it's like a mirror inside of a mirror inside of a mirror. It just would go on forever, and your computer would explode into little pieces. So they protect you from that.
Thank you.
Okay, so let's move on here. So let's see, a user connected, that's working for us. They're adding some other stuff here. So each socket also fires a special disconnect event. So on the connection, we'll say user connected, and then on disconnect, we'll say user disconnected. So that's a nice little thing to have. So I'll copy that. We'll go back in here. We'll delete that console that I added. So a user disconnected will happen whenever somebody disconnects. So that means if we go to here and we do this, it says a user connected, and if we just leave that, it says a user disconnected. So the user's gone, but if we go back, the user is connected again. So that's kind of cool. We can keep track of every time a user connects and every time a user disconnects. So we're able to keep track of whether or not a user is actually active within the application. That's kind of nice. And just remember that all of this, works really well and is really cool. And you could write it yourself, but it would take a lot of time. So all of this code is done. And the basic theory of it is pretty simple in terms of, connect to XHR and connect to WebSocket. You could do these things yourself, but Socket.io has done a lot of work to make sure that that's going to work very it's going to work very stable across multiple browsers, and that it's going to be, you'll always get those disconnect events and you'll always get those connect events, and you can create your own events and these types of things. So they've kind of turned something that many applications do on their own into like a standardized way of doing things, and it saves you like 10 years of development experience or whatever it would take to create Socket.io on your own. Okay, so now we have a disconnect event. So we're going to emit our own events now. So they're using jQuery. We can use jQuery. That's fine. So we're going to add this, and we're going to add this. So I'm going to go back here. I'm going to paste that in. I'm going to delete the stuff that was there before. So we're adding jQuery now. jQuery lets us say form.submit. So whenever the form is submitted, we're going to emit this new chat message. And so they're using this money m thing, so this money m.value as the chat message. So that's referring this. In the way jQuery works is that this sorry, not money m, but like hashtag m. A hashtag refers to an ID in jQuery. So we called our thing new message. So we would change this to new message if we wanted it to work with our existing code. What they're doing right here when they say, new message.value, and then they pass in like this empty quote, that's just clearing the message from the new message box. So you'll notice that our code didn't do that before. If I typed a message here and hit send, the message would still be in the input, but chat normally doesn't operate that way. It normally clears out when you send a message in chat. So that's all they're doing is just setting the value back to an empty string. So they're going to send the value to the server by emitting the message, and then they're going to set the value of the input back to nothing. And they return false, similar to how we did, because they don't want the form to be submitted, as we kind of walked through the reasons for that. So we don't actually have a form. They have a form, so we can just create a form. There's probably a server-side component to this. Yeah, so on connection, then we say socket.onChat message, and then we're just going to console.log that message. So let's see. So we're emitting the chat message event, and then over here, we're going to print the message that we received. So this string right here, chat message, in this string right here, chat message, they're identical. And here we're emitting an event, and here we're listening for an event. So on is our listener. So on chat message is what we receive on the server, and on the client we say emit chat message. So you could change this to whatever you wanted. You could change it to UIT, chat message UIT. It wouldn't matter as long as they're the same. And that's really cool because it means you can create your own events and things like that. So right now, chat message is a pretty simple example, but your application could have, tons and tons of events, whatever you think of. But anytime you want to send information from the client to the server, you're going to emit a message, and then you're going to listen for that message. So don't take it for granted, because this used to be really, really hard to do. But with Socket.io, it makes it really, really simple.
Hey, Gavin?
Yeah.
Could you hop back to your HTML?
Yeah, I'm just going to test this.
Yep.
That message is not defined, because our code over here that we wrote in index dot no, sorry, in script.js, the code that we wrote, is not being triggered anymore. So I'm going to change this back to a submit button because we're saying form.onSubmit. Form.submit. The input type submit. Value send. And then on click, we're not going to do that thing anymore. Actually, just for reference sake, I'm just going to comment that out. That's the way of commenting in HTML. Input type submit, value equals send, and then on click. We don't need an on click anymore. So this is like the raw HTML way of doing things, the way we did it before, where you said on click and you would call this add method function, and then add message function would, you know, do all this stuff and it would add a message. In jQuery, they simplify things for you and they make it like a little more obvious. So you have a form and the form gets submitted. In an input type submit, when you click send on that, it submits the form as we talked through. But in jQuery, you're able to kind of interface with that and listen to that in a very kind of intuitive way. So you would say $, which is the jQuery function name, and then you pass in form, and that's going to look for the only form element that we have on our page. And then .submit means it means the same as onSubmit. So if we said form onSubmit equals, you know, call something, like, you know, you're going to call a method. That's the exact same, like we're going to call a function right here on submit. So jQuery is doing the exact same thing. So you're just saying form.submit, and then this function, you're just kind of passing it in. So it's going to call this function whenever somebody does a submit. So we don't have to type all that stuff in our HTML, and it's kind of nice. So then we're going to call socket.emit and et cetera, et cetera. So we had to change to kind of work the way they want us to work with jQuery. We had to change our HTML structure a little bit to make sure we're not crazy. It's always good to test things out after you change them. So, I mean, some people develop for like, you know, 4 hours and they just type all kinds of code and then they say, okay, I'm done, and then they run it and then they hope it works. I like to just do things in very small iterations, so I make a couple changes and then I go to the browser and I make sure it's working. So just kind of every 5 minutes I'm back and forth between the browser after every change, and I never get myself in a position where, you know, I've spent 4 hours on something that just isn't going to work. Okay, so when I typed, you know, get new message, it's gone from here. Now we're not actually putting it on the page yet, but the server's receiving it, so that's super cool. So awesome. Okay, sorry, what was the question?
I just had a question about, you kind of cleared it up, if we should be using the input type as button, changing it to submit now does affect the form.
Yeah.
What do you do when you have multiple buttons? You have
Multiple forms?
multiple, yeah. You've got an input that doesn't just have one possible outcome.
Okay, so let's do that. So we had this button before called send, right? So let's get rid of the way that they're doing things. Let's get rid of this form. And let's get rid of this submit button, and let's go back to our normal button. We need a way to reference this button from jQuery if we want to know when that button was clicked. So the best way to do that is to give it an ID. Actually, I'll hold on to our original way of doing it. So we'll first make the change here, and then what we'll do is we'll add a second button to the page. So I'm going to get rid of this on message thing, and instead I'm going to add an ID to this. So I'm going to say ID equals send. So input type button, value send, ID send. And over here in jQuery, we need a reference to that send element. So I'm going to say hashtag send. And that's going to, what that's doing is it's the same thing as doing this. It's the same thing as saying document.get element by ID send. In jQuery, all you have to do is do this. And now you have a reference to the send element. So it makes things a little shorter. You don't have to type document.getElement by ID. It looks a little more modern. So I'll delete that. But we'll say ID send, and instead of on submit now, it's going to be on click. So remember before we just had on click add message? Now we're going to say dot click, and we're going to call the function that we pass into click. So make sure we're not crazy. So, okay, so it sent the message ASDF to the server. I'm going to set this up a bit more organized. Okay, so let's go back now and let's add a second button to the page, and we'll give it another value. So I don't know what an example would be, but let's say instead of send, we wanted like L or something. So the first one, let's say it's talk, ID talk, and the second one's L. Okay, kind of similar to Jake's power up thing. I thought that was a cool feature. So instead of send, we called it talk, and we're going to say, here we're going to say emit talk. Over here, instead of chat message, we're just going to say talk. And I'm going to copy that whole thing, and then we're going to make a new one called yell. So this is going to be talk, and this is going to be yell. Okay, so we have this talk thing. We want to copy that and create a yell one. So we need to just say yell on click, and instead of emitting a talk event, we're going to emit a yell event. So let's try all that, see what works. Okay, so now we now have two buttons on the page. The first one is like, why, hello, sir. And then the next one would be like, WTF, man. And so you see we have a talk event and we have a yell event. So what we did when we wanted to add two buttons to the page, so we kind of changed things up. We got rid of the way they were doing it in their example because it didn't really extend the way we needed it to. And instead of submit, with submit, it's always assumed that you have one submit button for a form, and when you click submit, it submits the form. But if we just use these regular buttons, we can have as many of those as we want, and as long as we give them unique IDs, then we can uniquely reference them, and we can create, any new types of events that we want, as long as we have that event on the client and we have that a listener for that event on the server. Does that answer the question?
Yes, that's awesome. Thank you.
Okay, cool. And I'll upload all this code again. I'll throw it up on GitHub when we're done. Okay, so what are they doing here? Okay, they're doing some stuff. So now they're saying broadcasting. The next goal is for us to emit the event from the server to the rest of the users. In order to send an event to everyone, socket.io gives us io.emit. If you want to send a message to everyone except for a certain socket, we have the broadcast flag. Okay. So broadcast would mean like send a message to everyone else but me. In this case, for the sake of simplicity, we'll send the message to everyone, including the sender. So emit sends it to everyone, and broadcast sends it to everyone else. Okay, so io.emit. So whenever we receive a talk event, so if you think about if we think about what they're saying here for a second between emit and broadcast, like before when we were just typing hey, there was no server involved in our original example. All we would do is just append the message to the page, and that's actually a really nice way of doing things because, like, let's say our server is on DigitalOcean and DigitalOcean's in Chicago. If I type a new message here, I want my new message to show up in chat because you want to know what you said to everybody. But why should that message travel to Chicago and back to me when we could just throw it on the page directly? So that's why generally you would want to use broadcast and not emit, because everybody else who's not, they're not on your local machine, the message has to be sent through Chicago, and then the server in Chicago can broadcast it out to everybody else. That makes sense for all those remote clients, but it doesn't for us. So, emit in this case, I think, isn't really the right thing to do. I think we would want to do a broadcast, and what we would want to do so that the sending client receives it is just throw it on the page locally. So let's do that. So socket.emit, blah, blah, blah. So that's sending it to the server, but on this side we should do an io.broadcast. And we'll call that.
No, it changes.
Let's call it talk, I guess. So we're just going to broadcast the talk event to everybody else. So we're receiving the talk event from one person from the socket, but we're going to broadcast it to everybody else. And the one thing we haven't done here is we haven't actually added it to our page. So in jQuery, we had this messages div, if you remember. So in jQuery, we would want to say $hashtag messages. That's like our document.getElementById messages. And I think in jQuery you say append. So we can just append some. We'll append the dollar new message value run that for a second, see if it's actually adding it to the page. Okay, it is, but it's not actually adding any space. So we would want to do that. Something has no message. Oh, socket.broadcast.emit, that's why. Okay, so maybe socket.broadcast.emit talk message. We don't have the other end of that set up yet anyway, but okay, so this append is working, but it's not really the best. What we could do is create a new div. So I think we can do that by just saying div like this. And then inside of that div, we would have a new message. So that's that's like what you would call like spaghetti code when it just becomes very kind of hard to read like that. So let's just see if it works. And if it does, we'll clean it up so it's easier to read. Oh, that's doing something really crazy. Oh, it's finding all the divs on the page and it's adding it. I thought that would create a new div. I think we have to do this like that or something. We'll create a new div. Okay, so that created a new div. Okay, so remember before we did like create element div? Well, that's what we're doing with this value in jQuery. So let's like convert all this code so it looks a little more like it did before. So our new message is going to equal this, instead of document.get element by the new message, in jQuery all we have to do is just say hashtag new message. Var. And we had the value, which was over here. We had var message equals new message dot value. So in jQuery, we would say var message equals new message dot val instead of value, because they're cool like that. And then we would say var messages before we had document.get element by ID messages. But now we're just going to say messages equals $, hashtag messages. So now we have that. Usually when I'm referring to a jQuery object like this, I like to put like a $sign in front of my variable. So it's $sign new messages, so that I know there's actually there's a difference between document.get element by ID messages and just doing this $sign messages. And the difference is that this is a reference to the jQuery, or a reference to the element in jQuery. And when you have a reference to the element in jQuery, you have access to jQuery methods like .val and things like that. And if you just have a reference like this, like document.get element by ID messages, you have a reference to the raw HTML element. So you only have access to properties and methods provided to you by HTML and not the fancy ones that jQuery gives you. Okay, so now that we have all that, we would say messages. Oh, we had one more thing. We had content. So var content equals, instead of document.createElement in jQuery, you just do money sign, and you do this little div tag like this, and that's going to create a new div for us. So content needs inner text, and in jQuery I think we can just say text, and it would be message. So message is the value from up here. And we have messages, dot append. Instead of append child, it's just append. We're going to append the message. So we should now be able to comment out this whole thing. And actually we would say new message val. So we're going to clear it. And you might want to put like comments in here, like clear the input field. So you know what you're doing, right? Well, at the time you usually know what you're doing, but it's like the day later or a month later, or if somebody else is looking at your code, that's when it gets confusing. So it's good to add comments. So undefined is not a function. So we're getting an error. So I did something wrong. And it says it's on, if we look over here, it says index :24. So that means line 24 in your file. So if we click on that, it didn't like this new message.value thing. And that's because, and it says undefined is not a function. That's because if, I realize it's really hard to see, but it says new message.value without the $sign. So that's not actually a thing. So we very quickly, just by going into the console, getting that error, and we always have the console open this whole time so we can see any errors that happen. And then we just click on that on the far right. We click on that, and it's going to jump right into the file, and it's going to highlight the line. And you see undefined is not a function. So this isn't a thing, but with a $sign it is. So that's for that. Okay, so now it's working. Almost working. It didn't. I don't like the way it did the div there. So we appended the message instead of appending the content. So message.append content, because the content is a div and the message itself is just text. In a div, if all of these messages were inside of divs, they would have a line break automatically. So if we look at the elements on this page, inside of our messages div, what it was adding is just adding these strings to the page. And the way that that actually renders in the browser is it doesn't know that there's a line break or anything. But if we put it inside of a div, then the browser knows to organize it one on top of the other. So let's refresh that, and let's do... Okay, so now it works. So if we look at the element, we would see that it's actually putting those values inside of divs. And that's what we wanted it to do because we created a new div element called content. So in some ways, this is a lot more code than this. But if you add comments to something like this, it's going to become a lot easier. So get the new message div at the value, then we'll say get the messages container, and then we'll say create a new div for the message, set the content, or set the text of the new div to our message text, and add the new div to our messages container. And then we already had this thing to say, clear the info field or whatever. So it's a lot more code, right? Like this is like a bunch of lines of code with comments and everything else. But if you were just coming back and you were looking at like messages.append, div.append, new message.value, it just takes a lot more brain power to understand what this like means versus just very clear like get the new message, get the value, get the messages container, create a new div for the message. This is very like explicit in terms of what it's doing. So let's just, in doing all that, make sure we didn't break anything. And like, there's really no right way to do this. If you wanted, if it was important to you to have a small amount of code, you would probably want to go with this instead, right? But if it's important to you, it's like easy for people to understand what you did, then you'd want to go with something more verbose. So it's up to you. It's really just a style thing. But doing that, going through and changing your code, making it, it's a different style, it's a different way of doing the, accomplishing the exact same thing, and that's called refactoring. So you refactor your code, and the idea there is that it's going to functionally, it's going to work the exact same, but it's, it might be a style that makes it easier for other people to look at your code later. Any questions?
Hey, Gavin?
Yeah.
Yeah, it looks like your laptop's going to die.
Yeah, it is. One sec.
Didn't want to lose all the code. Getting up.
Okay, cool. All right, so the only thing we have to do is test, like, actually we need to add, on the client side, we need to listen for new messages arriving. So let's do that. So over here, we need socket.on chat message. So blah, blah, blah. We're going to receive a message, but we called this talk instead of other things. So we called that messages. We called it this weird no vowel thing. Messages, .append, li, text, so new message. So the way they did all that this is very kind of similar where they said li, so this is creating a new list item, and it's doing messages.append. So it's similar to how we did it up there, but instead of doing append new message then the value, they just say text message. So this code's a little simpler because they don't have to grab the value from the messages thing. So we can actually, because they had a nice succinct way of doing it, we can actually use their way of doing it and just change our code kind of match their way of doing it. So let's see, messages. We still had our new message thing. So we'll say var message equals, don't have to create the li. We just need to figure out what message is. So that's money new message. And then dot val. So we're going to delete, actually, and then we still need to do this. It's kind of at the end. Okay, so let's just walk through this quickly for a sec. So before we were saying get the new message and then get the value. But that's really, it's such a small amount of code that we might as well just say var message instead of saying new message and then blah, blah, blah for these purposes. And then what they did was they just said messages instead of creating a value to store messages and creating a div separately. They did it a little more compiled where they just said, you know, messages.append a new li, and then they set .text to the message. So again, this is like a third way of accomplishing the exact same thing. If we didn't want this to be an li, we could make it a div. So, and then down here we would make it a div as well. I'm going to delete all of this.
Is line 38 really $sign new message?
No,
or is it the $sign number?
This one should be the hashtag.
Okay.
Okay, so delete all this. This doesn't actually exist right now. We actually did hashtag new message val. So we're creating it and we're clearing it. Okay, so let's just run that, see if it works. Okay, so you'll see it's adding a new div whenever we do it. So it works the exact same way. Instead of doing one line, and instead of doing 8 lines, we did 2 lines. So I think that's a nice compromise in this case. And again, you could refactor it 1,000 different ways. And ultimately, it's a style thing. Your user doesn't care because the user in all of these cases is just getting the exact same experience. But you as a developer, you might care. You might have, you know, a particular style you like to use, or if you're working on a team with a bunch of developers, usually you kind of agree on a style. So that way everybody is kind of writing code and not like if you get into like refactoring other people's code and stuff like that, it can waste a lot of time, and it can also be kind of like annoying or insulting for people if you're going in and like refactoring their code just for style when the results are the same, right? So everybody has their own style. As a single developer, pick your own style. If you're working on a team in an open source project or for a company or at a hackathon or something like that, it's nice to decide to talk about it beforehand what style you want to use. Okay, so that's all good. What we need to test now is whether or not an additional client can actually join this. And when that additional client joins, if they'll actually be able to send a message to us. So let's run these side by side. So if I say, yo, so he receives that message, yo, Okay. So that's cool. So we have a chat app now, and they're able to talk amongst themselves, and it's really super awesome. If I yell, nothing happens because we didn't actually set up the yell method on the client to do anything. So let's move on from here. The problem with this chat app right now is that if I refresh the page, all of the, well, I need my server to be running, but if I refresh the page, all of my messages are gone, except for those two default messages that we hard-coded. Everything else is gone. So, you know, I closed my browser by mistake or something, and I was talking to this person. If they're like, you know, sending messages while I'm not there, I have no idea what's going on. So it's kind of a useless chat application, depending on your use case. It could be a feature, right? Snapchat is a cool example of a chat application that doesn't use it. Well, they use a database, but they don't. They claim to not store any of your messages, and you send somebody a Snapchat. Once the person views it, it's gone, right? So they send it from client to client, and they don't store the message on the server. So maybe you know, depending on what type of application you're building, you don't need a database, and it's actually a feature not to store the messages. But in our cases, and in many cases, you're going to need a database or something. So let's go set up Redis now. Any questions so far? Okay, so this project you're going to add chat history. When a user joins the chat, the previous messages will be displayed. This project will extend your simple chat server, view Redis, install Node.js. So let's go install Node.js. Actually, we can npm install this. So npm install Redis. So we'll do npm install -s save Redis. Okay, so Redis is installed. Usage. So var Redis client key set blah blah blah. So Redis like has some simple concepts like just set and get. So let's copy this code. And so when you set, like, they call it key value. And when you set a key to a value, you can also do a get on that key to receive that value. And it is similar, as Matt explained in his demo. It is a similar concept to having a variable in JavaScript, where a variable has a name, and that name is like your key, and then you set that variable to a value, and then it remembers it. So that's all we're going to do here. We're just going to have a key, and the key has a name, and then we store a value inside of that key. I didn't copy that properly. Okay, so in Vim, you guys, I don't think many of you are using Vim, but if you shift V and then hit the up keys, it's like highlighting all this stuff, and then if I hit the equal sign, it just automatically formats everything. I'd like to select database 3 instead of 0. Okay, we don't need that. So there's this client.onError thing, and then we're just going to say client.set. We'll do something simple like app name or something, and then we'll set it to a value like simple chat. Delete all that. And then over here in socket.io, whenever somebody connects, we're just going to say client, which is our Redis client, dot get app name. Let's look at how get works in Redis. So get, when you do get, it returns this function with an error and a reply. So let's paste that in here. Format this code. It says reply is null when the key is missing. So we'll just console.log the reply. So if this works whenever somebody joins, we're just going to do a console.log to say app name is, and then whatever the value is that comes back from Redis. So we set that value to simple chat. So hopefully it says app name is simple chat. I want to install Redis again and then to run my server. Redis connection to blah 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 failed because you don't actually have Redis. So let's get Redis. Okay. Redis.io download 2.8.17 is the latest stable version. Actually, when I download this, I'm just going to copy link address. I'm going to open up a new thing here. I'm going to cd into my development directory. And I'm just going to do a wget on that. Hold on, I should have wget, right? Curl. Oh, when I curl, I need to put an output file. So minus o. I'll give it this name. Same name as the file. Okay, so I'm downloading that file now. So if I ls, you'll see Redis is right here. So I'm going to unzip it. Basically, this is a command to unzip things. Now I'm going to cd into Redis 2.8.17. And so there's a bunch of stuff here. I'm probably going to want to look for like a getting started, like QuickCai. Oh, didn't mean to download that again. So let me see. Documentation. Full list of commands. How to configure Redis. Use cases. And just do like install or running Redis or something like that. I'll just see what they say. Oh, there is a quick start. Okay. So I wonder why wget wasn't found for me. Anyway. So they cd into that and then they type make. So make is like a build command. So in here you can see there's a make file. So I'm going to type make. And this is doing a bunch of stuff. Redis is an application that's built in C++. So when we type make, what it's actually doing is it's following the commands inside of that make file, and it's building Redis. At this point, you can try if build works by typing make test, but this is an optional step. Okay, so let's just type that, make test. Oh, it looks like it's working. So what is... Why is this happening? I'm going to kill this thing. Maybe that's doing it. Okay. Anyway, are you guys still there? I don't know what that was. Redis server is the Redis server itself. So if you type Redis server, that's going to run Redis. So let's do that. And not found. So where did it put Redis server? cd into build directory. Oh, okay. Make install. Okay, now if I type make install, if I type Redis server, it's actually running. And it's running on port 6379, which is the default. So let's go back over here and see if we actually connect now. It says app name is simple chat. So we actually, when we ran the server, we successfully set a key in Redis, and now we're able to get that key from Redis. Any questions, comments, or concerns about that? See, the one thing that's really tricky about this is that if you haven't used Make before, and you haven't had to install something with Make, and you haven't had to download something to your client like that before, all of this can be very new and confusing. But what's awesome about it, and what you should be optimistic about, is that most applications like this that you need to download and install, they use the exact same process. So these commands that they're showing here, like wget and tar and cd and make install, this is something that you'll just do over and over and over again. And if you're getting into doing a custom install of like Nginx or a custom install of MySQL or Postgres or any of these other applications that you will end up using, it's just going to be the same process. So it was very fast for me to do this because I kind of understand how things should probably work. Even though the Redis getting started, like this quick start guide is really like, there's like too much information in here, and I couldn't find like a link to it from the homepage and stuff like that. But just having been through these things before makes it easier.
Gavin?
Yeah.
Does it matter whether you install it to your DigitalOcean server or your terminal server?
So right now I'm developing it locally, and I think, as Shauna mentioned in her presentation, like that's a good place to spend all your time when your thing's working, is just develop locally, and then worry about deploying to like DigitalOcean later. So I guess like you want to run Redis the way I'm running it now, where it's just on your local host and it's running on the default port. Just get that set up first, and then getting Redis deployed to DigitalOcean and running your Node server and Socket.io and all that kind of stuff on DigitalOcean is it's adding extra variables and it's adding more complexity. But once your application is working and it's working locally, then you can focus on just that, like the specifics of like getting it set up on DigitalOcean, rather than like being stressed out that you can't get it working on DigitalOcean and you haven't even got your application working yet, so you feel like you're starting to run out of time, right? So like just develop locally because it is simpler, and then consider the DigitalOcean thing like in after the fact. Like if you get to like the demo day on Friday and it's only working on localhost, I think that's fine. And consider it like a bonus to get it up on running on DigitalOcean. And then obviously, by the end of the project, you're going to want it up and running on DigitalOcean. But don't add that complexity. It's just going to like make things more complicated. Any more questions about that process? And I'm curious. With you guys, like having used Redis before, the way I think of it is like just get Redis installed, and then I'm just gonna like set some values in Redis, and I'm just gonna get some values from Redis, and I can totally see how just landing on Redis.io and just kind of landing on the Node project would be a bit overwhelming. So I'm just kind of curious to get your perspectives on it.
I think that part we actually did. We did most of this stuff correctly.
Yeah, a few of us have already done the installs. It's when you go on that Node Redis site that you were just on, Gav.
Yeah.
Go back to it. And you just see this wall of text. Scroll down. and it has all this like client string key, the hash key, all that sort of stuff.
Yeah.
And even though it does explain the get and the set and that sort of thing, still it's very difficult to look at that and see how that's going to interact with our chat UI.
Yeah.
And I'm sort of still guessing. I think now, having worked with it for a week, that the words hash key mean the name of the hash, but I'm not even convinced of that yet.
Yes. A hash is actually it's a useful thing that you probably would want to use for something like chat messages. I tend to like to start like really wrap your head around like just key values. So just use set and use get, and you can actually accomplish everything you would need to accomplish in the chat application just using sets and gets. And it's sort of a simpler paradigm because it's a lot more like variables. Consider the when you get into H set and H keys, which are going to return all of your keys. Consider that more like an array. It's more like an array in JavaScript, where it's kind of a grouping. So instead of hash key, you might call this messages, and then this would be like message 1, right? And then message 2, and then these would be your values. So it makes it really, really easy to just say like get me all of my messages, and then I'm just going to return all of my messages to the client when somebody joins the server. So that like if you think of it like an array, it is kind of simple. But when you're looking at the complex, like getting started with Redis, if you're looking at the complexity of all these commands versus just saying like set and get, it's a little scarier. Okay, so let's do a really let's get this working. Let's get this like message history working with like a set and a get. So let's see. When we send a message, we're receiving it over here. And so talk, we receive the message, we send it out to everybody else, and then let's store it. So we would say client.set, let's say last message. We'll call it last talk, because we're kind of distinguishing. So we would say last talk, and then we would say that equals the message. And then whenever somebody joins now, let's say client get talk. Function starts with an error and then a reply. And we can console.log last talk is the reply. Okay, so whenever somebody sends a message now, we're just going to keep track of just like whatever the last message was that they sent. Close out these. Okay, so last talk is null because we haven't, since we've done this, we haven't sent it any messages. So hey all talk. So talk hey all. So let's kill this right now, clear it, run the server again, and we'll kill this one. I'm sorry, too much stuff on there. So we'll run the server again. Oh, last talk hey all, last talk hey all. So Redis is now remembering that value. So what we should do now is we should send that value back to our client. So we could call that like history or something, like socket. Actually, we have our other. What's that code at the bottom? So let's do like socket down here. We'll say socket.on history. Function message. It will just be a single message for now, but it really should be multiple messages. Okay, so we're going to append whatever that message is. So over here, we don't want to broadcast it. We just want to emit it to the existing client. So clients, so socket.on, socket.on, socket.broadcast. Okay, so inside of here, I think we just do a socket.emit. We would say history. We would say reply. Let's see what that gets us. Refresh this. Let's talk HAL. So you'll see how that like showed up there. So hey, this was my last message. See you later. We'll send that. If I refresh the page, then that shows up. And if we go to our other client now, and we refresh the page, that message is always going to show up. The problem is that it's not really our complete message history. It's just like one message. So we should add a whole message history there. So we could just keep using a key value, and inside of the key, we just set like, just throw like the whole array in there. Maybe just like JSON stringify it or do something like that. But we should probably use hashes. So we could use hset and hget. So let's go back to Redis and take a look at those. So we say client.hset. It looks like this. So instead of client.set, which is down here, we'll call this history instead of last talk. So history, this is going to be like some sort of ID that we would want to keep track of. So where can we get an ID at? Probably, so if each message needs an ID, could just be a timestamp, but that's not really the best, because what would happen if two people sent like the same, or sent a message in the same millisecond? That wouldn't be the best. So you probably want to use something like auto-incrementing, so we can do that in Redis. I think there's like increment. Give us an example like that. Okay. Actually, there might be a better thing that would just automatically give us new values instead of hset. What does mset do? We'll look at Redis docs. No. So we get increment. So this is a really cool thing in Redis. If you go here, you can like mess around with things. So you see increment my key 11, and then get my key is 11. So if we type increment, this is actually interactive. Great way to learn Redis. So if we just said increment my key and then increment my key, and then get my key returns 13 now that we did that twice, and probably we can just do like decrement my key, and we could say get, get my key. Now it's back to 12 instead of 13. Okay, so we could use that and just keep track of message IDs. So let's do that. So I wonder if you just do like increment on something that doesn't exist, what will happen? Like if we just do increment message ID. Yeah, so we'll just start it off at 1. So we don't even have to do anything to set it. So we just say message ID. Okay, cool. So let's do that. So client.increment message ID. We returns a function. And we would say client dot just do console.log. And it probably returns a reply. So let's just do testing. So let's just see what happens when we call increment each time. This is happening whenever we send a new message. Okay, so testing 1, testing 2, testing 3. So it's giving us like a unique message ID every time we run that. So let's just do message ID. Message ID. So reply. Okay, so now we were going to do our client.h set history, and the ID is just going to be like our reply. We can actually give that like a name like this, like message ID, so that we know exactly what it is. Makes our code easier to read, and some value, and we know that our value is going to be the message. Let's do that. Let's get rid of this last talk stuff. And console.log. We're not going to get, we're going to do, what was it, H keys. H keys returns a whole bunch of things that we can iterate through. So client.h keys. We're going to call this history. And they call this replies because there's many. History. And then this would be replies. Okay, so we're not done yet because we're not actually iterating through the history messages, but let's just see what happens if we're actually able to keep track of multiple messages. Emit history. Okay, so that's all right. Okay, so it's saying, hey, 1, message ID 1, message ID 2, let's say what's up, message ID 3. Let's refresh all this and see what happens. So it just returned 1, 2, 3 over here, history 1, 2, 3. So it's returning some array where we just have these values 1, 2, 3. So let's see how we get those values out of Redis. So let's see. They're doing this thing, replies.for each. We get it working. So what they're doing here, replies.forEach, is we're just going to loop through each of the replies. So for each reply, we're going to return a reply, and we're going to turn I, which is a value. So, and we're just going to console.log it to see just what we're receiving back from Redis there. 1, 2, 3. So what I don't like about this is that we're not actually getting our message back. We're just returning this reply thing. I wonder if we do like reply, reply, and then I, something like that. Undefined, undefined. So where's our message at? We need to find this. Maybe let's just play in the Redis console. So we can just say hset history 1 go 1. If we do h keys history, we're just returning all those keys, but we want to do like an hget. So hget history. What does that do? Wrong number of arguments. So we need to say like hget history 1. And that returns our thing. So that's what we're going to do. So for each of these, we have to do an hget. Sorry, client.hget. And we need, well, reply or I. What would be better to use? They seem like they're pretty much the same. So let's just do reply. Yeah, reply would be the right one to use. Client.hget. Reply, or sorry, history, reply. And this should return a function, an error, with an actual message. And we can say console.log message. Client join. Okay, so message hey to, what's up? Okay, so every time somebody joins. So what we want to do now is we want to actually send those to our client. So we get our history, and we want to make sure our history is in the right order. So for each of these, we're going to send a message. Okay, so you see how our messages are showing up now? Hey, what's up? And we can make this other client join over here. And we can just say, oh, nice. You nice. Yo, nice. And if this person was like missing while we were saying these things, like, hey, where did you go? And then if he were to join over here, then those messages aren't lost. So you kind of get all those messages. And it's nice, you can refresh the page, and the messages are still there. I think there's a bug in all of this, because I think when the clients disconnect, so they have all their messages there, and I think if we bring the server back and they reconnect, they're getting all the history again. So that's like, something that you would want to fix. Another problem here is that what we're actually doing is we are grabbing all of these messages out of the hash, out of the H keys, and then we're taking each one individually, and then we're sending it individually to the client. And because of the internet, there's the ability, or there's the possibility that these messages would actually be received out of order. So we would actually want to do something where we just loop through and we grab all of these, and then we put them in a JSON object, like an array or an object, and we send that back to the server all in one bunch. And then on the client side, what we receive here, instead of individual messages, is we would want to receive the array of messages, and we would want to do our for each iteration on this side instead. So I mean, we could refactor it to to do that. It's just really, it's like an efficiency thing. But apart from like a small potential bug right now, it's working. So I'll just stop there and just see if you guys have any questions related to that.
I have one question. Where Redis is running in memory, would you still have that problem with the values becoming out of order?
Yep.
The asynchronous setup.
Because so what Matt is like referring to is similar to the like passing them back over the network individually and having the possibility that the messages could be received by the client out of order. We're actually communicating with a server right here as well. So our Node.js server in this case is a client that's communicating with a Redis server, right? And right now that Redis server is like sitting on the same machine as us, and we're communicating over localhost. And so similar to our web client, like there's really a very small probability that messages will be received out of order, but it's possible right here as well. So you would want to instead figure out what Redis method would allow you to just grab all of these keys from Redis in one bunch and then iterate through that. Like that would probably be called, I don't know, hvalues or something like that. I'm not really sure. Let's look at commands. Get all the fields and values in a hash. Keys, length, get the values of all the given hash fields. No, that's set. Is there just like an get, or is there the value of a hash field get all? So I think we want to do an get all, and that's going to return this type of thing. So let's just do that. So instead of even doing, so let's do like a refactoring here now. And when I refactor, I think it's a good idea to kind of like keep your old code right here, and then put your new code above it, just so if your idea is actually bad, you can still get back to the thing that worked. So let's say get all. That's going to be very similar. It's going to give us some replies, but the replies are going to be better, and we can probably skip this whole set right now. What I'm just hoping we can do is skip all that. And I'm just going to comment out this whole thing so it doesn't run right now. And let's just see. We would just say like var message equals reply I. Or maybe just reply. Probably just reply. So instead of sending back the message here, we're just going to send back the reply. Let's just see what happens. It has no method for each, so it didn't like that. Where did that happen? History.get replies. History replies returned that object, but it didn't have a for each method. Okay, so we can't do for each, but we could probably do like a for. So now. At 64. Something's wrong with this, so I forgot to comment this chart out. Okay, so it said 1, 2, 3. Okay, so that's the right thing. So our message is actually in this replies I thing. So var message equals replies I. So like everything I'm doing right now is really just based on like an understanding of JavaScript and the different object types. So I know that they're returning an array to me, and actually, and not an array. It's an object, kind of similar, but I'm just gonna loop through, like use the for loop to loop through that replies object that's being returned to me, and then I know that each thing inside of that object is actually a reply, or is the message that we want. So let's do like an emit like this. Oh, reply is not defined. I meant to put message here again. And we're going to change this whole thing again because we actually don't want to iterate through all of these messages on the server. So you'll see that's working now. We don't want to iterate through them on the server. It's actually better for us to iterate through on the client. So I'm just going to do socket.emit history, and then we'll just send all of the replies at once. And our client right now is not going to like that because it's set to receive not an array. It's set to receive a single value, but let's just see what happens. So it's receiving an object. It's putting that object in the page, and HTML can't display that. So over here, we would actually take, instead of iterating through this on the server, we could iterate through on the client, and we could say replies. And instead of emitting in that case, we're just going to set it in the HTML. So our sanity. Okay, so you'll see what's being returned to JavaScript is actually the full array, and now we've fixed that problem. We had two problems before, which would be called race conditions, where it's possible that our messages could get out of order, either talking to Redis or by sending them back to the client, and we fixed that. So it's not an actual bug that we were seeing, but it was more just a possibility that they could get out of order. So we kind of got in front of the problem and we fixed it. We looked at the Redis documentation and we clicked on commands, and we knew we were doing like an H, get, or we knew we were doing an H set. So we kind of looked at related commands inside of Redis, and we saw this that there was this H get all thing. It would actually give us all the fields and values in a hash, and we figured that would be useful for us. And we got rid of like all this code here, which was kind of like complicated and hard to read, and we replaced it with this nicer code here where we did hgetAll, we console log them, we emit them to the client in an array, and then we loop through that array on the client. So now socket.onHistory just receives a whole bunch of replies. We just have to do a for loop to kind of go through those replies, and then we just append each reply we could clean this up by getting rid of the console log there. We go through the replies to put them all. I wanted to delete this. We loop through the replies, and then we just append each one to the HTML. So that was a good question by Matt, and it led us down the path of refactoring things a little bit. Any more questions related to this? I know I'm going kind of fast, but that's what I plan to do. In some senses, I'm kind of going slowly through this, but I planned on just kind of like ripping through all of this and just kind of doing it the way I might do it, the way I might get it working, and then letting you guys just kind of, I think just like witness me doing that. But then you can ask questions.
Yeah, I was just wondering if, like, without getting too in depth, if you could just quickly go through everything you've done and just kind of summarize everything from.
Yeah, sure. So I'll do a quick recap. So we started by setting up a simple client, and we just wanted to, like, as quick as possible, just like, okay, we know we're gonna have an interface that looks something like this, where you have messages on the page that you can just add. So like we knew there'd be like an input and some kind of button. I know a lot of you got rid of the buttons and you just listened for like the enter key. But whatever, it's all similar. You're like typing somewhere and then you're adding messages to the page. We didn't really spend any time on the style because it was just simpler to get it working this way. The next thing I would do, now that we have like basic functionality working with sending messages and having a friend be able to join us and being able to send messages to and from the friend, and having the history so that if I'm not there, I don't miss any parts of the conversation. It's a very basic like functional chat app, but now I would spend some time making this look nice. So I would probably like go look at like Twitter Bootstrap, and Twitter Bootstrap has a nice whole bunch of like components and things like that. And if you look at the CSS sections, there's like nice buttons and nice forms and nice tables and all these things. I'd probably start there. Let's see. There's a bunch of like examples that they have too. Like there's examples down here, so I might find something that would like work for me. I don't know. Maybe this would be like maybe this thing even would just be a good place to start. Like just get these form elements and this nice button and stuff like that. But like there's a lot of cool examples in here you can just mess around with. Anyway, like I would like play with the style next, and I would make things look nice, right? So after just getting this basic like UI part working, it's ugly, but it's functional. I wanted to set up my server. So to do that, I installed Express and I installed Socket.io, and I added this basic route which would serve my index.html file, and I then added Redis. So once we had Redis added, we needed a basic way of just storing our messages in Redis history. So we had to get Redis installed. We had to use make, and we had to figure out a strategy for Redis, and we had to do a bit of kind of exploring. It was faster for me than it might have been for you if you've never used Redis before. But basically, my strategy would just be to like hang out in this command section and just read some of these things and just kind of get familiar with some of the concepts in Redis. We know that there's like sets and there's gets and there's h sets and h gets, but there's all these other things too. So what do these things do? Because maybe by learning the capabilities of Redis, we would be able to figure out an even cleaner way of doing things, right? And you can click on these things and you can mess around. You can try the commands for yourself. And stuff like that. So I don't know. It's I think just kind of having a strategy, and I think if you can take anything from it, that strategy should be to like start really simple and have like very like bite-sized goals that you can have, and that's why we kind of broke the project into like start with the UI and then start with the server and then think about the database. That's like a general strategy that works pretty well. And the next thing you would want to do is you would really want to think about like how to make your experience look really nice now that you have those basic functional pieces in place. But yeah, any questions? I can't hear anything right now.
I think we're good.
Okay.
One sec, we might have a question.
I got nothing.
Yep.
Got it.
So I'm going to go git status. I changed a bunch of stuff. I'm just going to do git commit -am, and I'm just going to say, basic working chat app. I'm going to git still says untracked files, so I'm going to git add hold on. Git add index.star. So there's two of them. Git add package.json, git add script, git add style. Git status again. I don't need to add these swap files. I'm actually going to add a git ignore. I'm just going to ignore anything with .swap in it. Star.swap. Okay, so I modified git ignore, so I'll git add .git ignore as well. I'll do git status again, and then I'm going to type that whole thing that I had already, git commit.am. If I type git status, git push origin master. So pushed all of that, and now you guys can see that code in simple chat. And I will paste that into HipChat. And I'm trying to think. I mean, I think basically get familiar with get and set in Redis, just get set, get set, get set. Get really used to that, because there's we could have actually made that work and stored all the messages just in get and set. But being a little more comfortable with Redis, we looked into hget and hset, and that for our purposes in our data structure, that made things actually a little bit easier. So this week, you guys are going to, I think probably play around with Redis a little bit and get it working. But on Friday, the idea this Friday is that you'll actually demo a slide deck. So rather than doing a regular demo of your product, you're going to present your deck in a pitch for your chat app. So this week you can have a little more fun, take a bit of a break from the technical stuff. If you spend any time on the technical stuff, kind of do research into the areas you're not comfortable with, but take a bit of a break from it and just have a bit of fun this week, getting creative with your chat product and thinking about features that would make your chat product unique, or a market that would make your chat product unique, maybe a chat application for doctors, or a chat application for lawyers, or a chat application for hockey teams, or or a chat application for hockey fans, or a chat that sends self-destructing messages, or whatever features or ideas or whatever you can think of for your chat. The basic idea this week is to focus on that, and to have some fun with it, and if you have time, even get into your work on your deck, but get into your chat app and kind of, mess around with some of the colors and with the name of it and stuff like that. And just come up with a unique. I know some of you have unique angles for your chat already, but not most. A lot of people have been focused on just the technical side of things. So this week you can have a little more fun with it and try to come up with a unique angle. So I would attack it two ways. Either spend time actually adding those whatever features you think of to the demo. Or just take a break completely from the development and just work on a deck, like where you can just theoretically say, like, this is my market, these are the features, this is what makes my chat product unique. Cool. All right. So any more questions at all, or anything that you guys want to focus on, or are you all good?
Yeah. Do you still want the pitches to be 5 minutes since they've been in other presentations? Okay. Gavin? Oh.
Hey.
There it is.
Can you hear him? Okay.
Yeah.
So timeline on these presentations still 5 minutes?
Yeah, spend 5 minutes per presentation. I think the difference this week is really pretend it's more of a pitch, right? It's more of a, this is actually a product, or it's actually an idea that you have. If you want to get your point across through a demo, that's fine. But everybody should definitely have a deck, and try to, pretend you're actually pitching to investors and you actually wanted, money to, pursue this idea. Then how would you pitch it? Or if you were pitching to customers, right? You're at a conference and you're pitching to customers and you want them to use your chat product. How would you pitch it? What makes your chat product different? And actually work on some of the slides that kind of show, just using the example, if you had like a chat product for hockey fans or something like that. Well, what sort of features would you want to add to that chat application? You don't have to build them all this week, but just put them in your deck. This product for hockey fans gets automatic updates from NHL.com whenever there's a score, or it allows you to follow certain teams, and you can chat, about the Montreal Canadiens, and all the scores will come from, or any Twitter stuff that's happening based on the Montreal Canadiens will flow into the chat room, or just like whatever. But it's just like, just have fun with that creative process and just pick something that you think could be like a viable use case for a chat product, and mess around with the features and put the pitch together.
Okay, that sounds good. Perfect.
Cool. Chat for NHL.
There's quite a delay on the video.
I know. Thank you.
Yeah, thanks,
Thanks,
Gavin.
man. Thank you.
Yeah, that made everything a whole lot more clear.
Yeah, hopefully. I'm sorry it was long, but it hopefully gave you like a perspective on how I would approach it.
Yeah.
No, that flew by.
Mike can let us know if the recording is good.
What was that?
I think that's what it is.
Yeah.
Cool.
Okay, guys.
Thanks.
Thanks, Gavin.
Thanks, Mike.
Yeah.
Hey, Mike.
I'm with this.
Is Slack hackable? Like, I think I read that you can like make plugins and extensions for it.
There's a lot of information.
Yeah, I was thinking about even making my own. Like if we spent a couple days doing that and built like UIT specific integrations, I think that'd be awesome. Even if it was just me, but yeah.
Yeah.
Cool. Anything else, Mike? Thanks,
Thank you.
Mike.